A question I often get is, it's all well and good to train these models and deploy them within a Jupyter notebook, but how would I use these models in the real world? How do I actually connect the output of these models, of these machine learning models, to a real application like a mobile phone app or a website or something like that? Well, that's a whole world of itself. We're getting into the world of actually designing larger systems here, but I'll give you some high-level guidance anyway. Now, obviously, your external applications aren't going to be running Jupyter notebooks and getting its results that way locally. What we need to do is separate the process of training and tuning our model from the process of actually making predictions based on that model. So the training part can all be done offline, right? We can do that within our notebook, or we can export a standalone Python script that gets run periodically, perhaps, to pick up new training data as it comes in. Maybe it's even running in some sort of a streaming environment. But that can all happen on the back end. You can still use your notebooks for that if you want to refine it. But then when you actually have a trained model, remember, we just have a model, like a classifier, that's sitting there in scikit-learn at that point, and all we have to do is call predict on it to actually get a result. So it's possible to actually export that model to a file and execute that model on a web service. So the idea would be to push the model out to a web service fleet. This could be like something on the cloud somewhere where it's just running a distributed set of services where hopefully you don't have to take care of the actual servers themselves. And all that service does is respond to web service requests over REST or some other interface. It says, here's the feature data that I want a prediction for, give me a prediction. And that pre-trained model that's deployed to that entire web service can then quickly provide that result back at large scale and at hopefully low latency and high transaction rates reliably. So your app would call the web service that actually just generates predictions based on the model, but the model itself is created offline, and then the results of that model, the model itself, is pushed to the web service. Let's talk about some more specific examples here to make it real. Let's say you're using Google Cloud Services. One way you could do this very easily is to just use the sklearn externals joblib method here. With it, you can just say joblib.dump with whatever your model is, any classifier, which can be anything, right? K-means, you can even have a deep learning classifier in there if you want as well. And scikit-learn can dump that out to a file after it's been trained. You just give it a file name, and for Google Cloud, it wants it to be called model.joblib. You would then upload the resulting model.joblib, which contains the model itself, to Google Cloud Storage, and from there, you can just say, this is going to run within the scikit-learn framework, and it will know what to do with it. At that point, you can just tie a Cloud ML engine into it, the Google Cloud ML engine, and that will expose a REST API that you can call to make predictions in real time based on that model that you uploaded into Google Cloud. See how that works? So basically, you would train your classifier offline in a notebook or whatever, however you want to do it, export that classifier to a file, upload that file into Google Cloud Storage, and then Google Cloud's ML engine could actually interact with that with your applications over a REST API. And if you don't know what a REST API is, it's basically the same protocol that you use for looking at websites. So when you go to your web browser and say, I want to look at this URL, that's sending a REST GET request to a server somewhere that says, I want to get the results of this URL, and it gives it back. In the same exact way, your application would say, I want to get a prediction for this set of features, give it back to me, please. Same exact mechanism. You can get a lot more complicated too. Let's say that you're using Amazon Web Services and you wanted to build an entire end-to-end system that makes product recommendations. One way to do this in AWS would be if you have a fleet of servers that are generating order data. If you're actually monitoring the servers where people are placing orders, we could have a service called Kinesis Data Firehose running on top of those servers that is feeding those log data information into Amazon S3 storage. And from there, Amazon's Elastic MapReduce service could be consuming that log data from S3. Maybe that contains all the purchase information or all the view information or all the ratings information for the stuff that we want to recommend. And on Amazon Elastic MapReduce, we could be running Apache Spark across an entire cluster that's consuming that data from S3 and creating predictions, creating recommendations based on that data. Now, in this case, I'm not going to push the actual model itself out to a web service. I'm just going to push the results of it out. So what I could do is pre-generate recommendations for every user ahead of time. So after consuming all of the latest data from S3, all the latest purchase data or ratings data, whatever you have to work with, I can go off and use Apache Spark to generate predicted recommended items that people might like for every user in my system. I could then publish that to something like Amazon DynamoDB, which is just a NoSQL database that will allow me to very quickly associate a list of item identifiers with a list of user identifiers. And that will be a very fast way of looking up what items should I recommend for a given user. So I take the output of the model and I publish the output to something more scalable like DynamoDB. DynamoDB is horizontally scalable, so it can handle very high transaction rates at very low latency. Then to expose that to the outside world, I could use something like AWS Lambda, which is their serverless functionality that just lets you write very simple functions that would access that DynamoDB database for a given user and retrieve the results back for some application. And it does it in such a manner that you don't have to worry about actually provisioning server capacity to run that. AWS takes care of all that for you. In front of that, you might have something called the Amazon API Gateway, which actually would provide the REST interface that your mobile apps or websites would actually talk to retrieve that data. So looking at it from the other direction, your client application could say, I want to get recommendations for this user ID. It would say, okay, Amazon API Gateway, give me recommendations for this user ID through some REST query. Behind the scenes, that would transfer that request to AWS Lambda, which again has to be scalable. Lambda would say, okay, I'm going to take this and execute a little bit of JavaScript code or something to retrieve the actual item IDs in DynamoDB for that user ID. And that was all pre-generated by Apache Spark running on EMR, creating recommendations off of Amazon S3. So this is a more complicated way that is more of an example of sort of the things you might see in the real world. These systems do tend to get rather complicated because as soon as you start dealing with massive scale, you need to deal with the cloud at some point. And you have to deal with technologies like Apache Spark that can scale up to massive data sets. So this is sort of a more advanced example, if you will, but a very real one of how you might actually implement something like that in the real world. Again, the key is that the actual generation of the model is separate from the vending of the data, the results from it. So on that top row there, that's the process of actually building the recommendations themselves, but then we push the actual recommendations down to something that's more scalable, to DynamoDB fronted by Lambda, which is ultimately fronted by Amazon API Gateway. And then we have a end-to-end system that can actually handle vending the results of our model at massive scale. There are other ways of doing it as well. You could just write your own web service if you wanted to using Flask or something, or whatever web service framework you like. You would then have to obviously provision your own servers and maintain them, which isn't a whole lot of fun. I mean, that's why people use services like AWS and Google Cloud and Azure these days. Also, you can go all in with a platform. All of these cloud providers tend to have their own systems and technologies for doing machine learning these days. So below here is like a partial list of the AWS services that are available in the machine learning space right now, for example. So, if you just want to do speech recognition or image recognition, they have services that are available off the shelf that will just do that for you. And you can obviously integrate those very easily with other AWS services to build larger systems like the ones that we've been looking at here. So something to consider as well, although it's always going to be a good idea to sort of prototype new ideas offline in a notebook or something like that. But ultimately, the way that you implement them for a larger system could be very different. So I hope that gives you sort of a high-level idea of how you might actually go about exposing your models to a real-world system. Again, the key insight is to separate the generation of the model itself and its results from the problem of actually serving those results to a massive fleet of consumers of that data. Whether you go with AWS or Google Cloud services or roll your own or use Microsoft Azure, I mean, those are all the topics of entire courses of their own. Like I can't cover that in a whole lot of depth right now, but at least that gives you a starting point of where to explore if you are in a position of trying to deploy these results to someplace real.